Hey everybody, my name's Sam and today we're going to be looking at how to enhance your Cisco browser configuration with DNS, and we're going to be including a practical OSPF example. This is going to form more of a tips and tricks kind of like short video rather than covering a whole topic. And also resources and stuff like that I'll be using will be included in the description. So let's get straight into it. So what is DNS? So realistically at this point, if you're watching this video, you should probably know what DNS is, but we're just going to cover it a little bit anyway. So just a reminder that DNS is a hierarchical system split into zones, and here's a couple key terms that we'll cover now that I will be referring to in the video. So what is a resolver? The resolver is the process or the thing responsible for querying DNS. It's not a very technical term, but I think it gets the job over. And a DNS server responds to the queries, which come from resolvers, with appropriate records. A DNS server that you configure as a server could be a resolver if it's resolving another server to get information. And a record is the actual translation. E.g., you could query a DNS server for the record of mail.apple.com, and it would respond with 17.2.1.2. The records are what are stored on the server. It's not what you actually get back. So why would we want DNS on routers? So for example, you were a new technician and you wanted to ping a router, but you didn't know the IP address for it. Now you can actually ping for what it's actually called. So you could see what we've done here is do ping R2, and it's pinging it because that router will have the records for that thing on the router itself. And this makes it easier for new technicians. It makes working with routers semantically better. This is specific for Cisco, but there'll be other, if you're working with Juniper or HP or something like that, I'm sure there might be alternatives. And it also means that you can change the underlying address structure. So for example, I doubt this is what they do, but if you're working at Google, you could change your server addressing, but your google.com would still remain the same. I doubt that's what they do. They probably do some very complicated cloud-based load balancing thing, but in a less technical organization, you could do that. And also you could do it combine it with automation, so you could have this and automation, or just automation. So there are a couple of considerations. So DNS is an extra layer of complication, and that means there's an extra layer of security risk as well. So DNS spoofing is when attackers target your DNS, and the real danger with this is you could be if your DNS is spoofed, you could be getting incorrect records back or incorrect translations, and that would be, you'd be awful because you'd be getting the wrong domain IP addresses, which would be a major breach of a confidentiality and stuff like that. So so then IETF came up with this solution, which was DNSSEC, and this was designed to address security threats against the DNS. However, the problem with this is, if you were going to implement something like this in a production environment, you got to make sure the routers or the switches you're configuring support this. Not all do. Implementing DNSSEC, you got to just make sure that if firewall rules are set up, so stuff like that. And another consideration that you've got to take into account is the management plane has more traffic to deal with. This is probably negligible in most cases, assuming you've got your network segmented properly. But it is an extra consideration that if you have loads and loads of records, it may be something to consider. So this is our environment. We can see that the loopbacks have been configured on all the routers, and this is our DNS server up here. And also, prior to this, I configured OSPF running across the network. So we're going to configure R1 as our DNS server. So here. So that's going to be our IP DNS server. Now, I did say the IP name lookup was enabled by default, but you just type IP name, IP domain lookup, and then so now you'd actually configure your records. So we want to have the loopback, so IP host R1 172.16.1.1, IP host R2 172.16.2.2, and then IP host R3. Oh, sorry, I did that last one incorrect. And IPR3 172.16.3.1. Now we can see what we've configured by show hosts. So do show hosts. We can see that actually so the name server it's itself, and R1 is 17. We can see all of that information. It's a type IP address. So now that's all configured on R1, which is acting as our DNS server. Say on R2, so we go enable conf t. So we want to point to this DNS server. So IP name server. We're just going to do the IP address of this internet here, interface here. So that's done. And then we're going to do the same thing on R3. Enable conf t IP name server 192.168.1.1. So from R3 we should now be able to do ping R1, which will ping its loopback interface, because we can see it's pinged, it's querying the domain server, the DNS server. It came back with a response, which is what it should be. So I configure that incorrectly. Ping. No, I haven't. And then it's come back with a response. And if we do ping R3, and that's what you'd also expect. So everything is working correctly. Now we're going to be looking at this in terms of implementing it in OSPF. So for example, in OSPF, we have this router 1's been configured a router of ID of 1.1.1.1. This one's 2.2.2.2, and this one's 3.3.3.3. You might want to swap that so it's an actual host name, and then using OSPF you can actually do that. So on R1 we're going to do some translation. So instead of this time putting IP addresses, we're going to put router IDs. So IP host OSPF R1. We're going to put 1.1.1.1. IP host OSPF R2 2.2.2.2, and if we're going to go 3.3.3.3. So to enable this thing, we need to do IP OSPF name lookup, and that needs to be done on all of the routers. So it would be IP OSPF name lookup, and then R3, and then conf t IP OSPF name lookup. So now when we do our show OSPF neighbors commands, it should say the neighbor IDs as what we've configured in our DNS, rather than the actual router IDs, and that is enabled by the OSPF name lookup command. So this is a practical example of something you might want to use DNS for. So yeah, just a reminder that the command is IP OSPF name lookup, and yeah, that's pretty much it. I'm sure there's other ones with other protocols, but you can look at that yourself. So thank you very much for watching my video, and I hope you guys found it very informative, and stay tuned for more. I'll probably be doing a looking at a Python script I did looking at the eGrip algorithm and stuff like that, and it lets you put in all different metrics and it comes out with another metric, the eGrip metric, and yeah, that's probably what the next video will be doing. So thank you very much for watching, and hopefully you can hear from me again soon.